These examples here are really just kind of the same as the ones we just did. So these are just practice. So try to do these on your own first. And we're just going to take the sketch of the original graph. So I'm just going to plot this original graph. It's going to be a y-intercept of -1 and a slope of 2. So maybe I'll start at 0, -1 here. Go to -1, -2. And these coordinates are going to be, looks like -5. It's going to be -3, 1, and 2. So this will be +1 and +3. So then we sketch this graph. It's going to have sketch a few coordinates here. So it's going to go through the y-axis there. It's going to go like this. Now the point that we're really interested in is the 0 point. So I really need to put that 0 point in here. And at x equals 1/2, y equals 0. And then this is going to give us our undefined value. And that's going to be where our vertical asymptote is. So that's really important that we locate that 0, because that's going to be our key point. We have our invariant points, and then we can just sketch the graph. It's going to go away from the x-axis here. It's moving away, so the graph is going to go towards 0 on the positive side, and it's going to go up the asymptote this way. On the negative side, it's going to do the reverse. It's going to look something like that. Okay, so there's our function. We can plot a couple points here. This is going to be -1/5, -1/3, 1. Yeah, that's our invariant point, and -1. That's our other invariant point, and +1/3. This is a parabola. We have a vertex at -2, 0. And we can plot a few points. So -2, 0. We'll go -3, -4, -1, 0. So at x equals 0, y equals 4. And the graph's going to look, our parabola function is going to go through here like this. And up like that. Okay, so there's original function. -4, 4. 1, 1, and 4. So the key point again is going to be our 0 point, because that's going to give us an undefined value, and that's going to generate our vertical asymptote. Now notice that this graph is entirely on the positive side of the x-axis, so it's going to be all positive y, so the reciprocals are all positive. So when I sketch this in, there's my invariant point. This is going to go towards positive infinity on this side. It's going to go down to 0. And on this side, it's going to do the same thing. It's not going to go down. It's going to go up the same way. So when we have this bounce on the x-axis, the reciprocal ends up going the same way. So I'm just going to fill this in, and I'll explain a little bit further here. So when I look at this graph, it's going to look like this. Y equals 1/x plus 2 squared. And so this is called when we have a squared factor, we call it a multiplicity of 2. When we have squared factors in the denominator, we actually get vertical asymptotes that look like this, where both, instead of pointing in opposite directions, one up and one down, on opposite sides of the asymptote, they point in the same direction. And that's a feature of these squared factors in the denominator.